Hello everybody, David here, and if you've been watching my videos, you know that I have this stuff on my bicycle. Let me walk through the parts one by one. So first you have a dynamo. This is attached to the rear wheel. When the rear wheel spins, and both wheels spin when you ride the bike, it generates electricity. So the generator spins and it makes alternating current, which I then put through this full wave rectifier right here. And that comes out to charge, or not charge, to energize this load right here. Now this load is a voltage regulator in real life. For the sake of the simulation, I put a 20 ohm resistor. But in real life, it's a voltage regulator with a USB port. And what I do is I take my tablet, my Nexus 7, and I mount it on the bicycle, and then I run a USB cable from the USB port over to the tablet, and that charges the tablet. This thing right here is a voltage meter, or a voltmeter, and I do have that on my handlebars, so this part is on the bicycle as well. Now what I noticed this morning, after doing some measurements on the tablet with a meter plugged into the USB port, was that the tablet was only charging at 1 watt. Now the normal wall charger puts out 7 watts, and the tablet uses 6 of them. So 1 watt is kind of slow in comparison. And in fact, if I want to run GPS with the screen on, I'm going to need at least 3 watts to keep the battery level constant. And if I want to charge, I'm going to need 5, 6 watts. So what gives? Well, what I noticed was that when the tablet is first plugged in, or when it first receives electricity, it sort of samples, if you will, the charger that it's plugged into. And it says, how much power can I draw from this charger? And if it's the regular wall charger, it's, oh, I can draw 7 watts. Well, I only need 6, so I'm going to use 6 watts. And it starts drawing 6 watts and charges the battery with 6 watts. But in this case, on the bicycle, what's happening is when the generator is first spinning up, which, if I'm at an intersection, I'll stop the bike. Or if I'm just getting started, the bike will obviously not be moving, and I'll start. And the generator is spinning up. But as it's spinning up, it won't produce as much power as it does when it's spinning at full speed. And that's true for all generators. They need to spin up. So what happens is, initially, it only supplies about 1 watt. At the voltage that the tablet detects a charge, it only puts out 1 watt. So the tablet says, okay, I detect the charger. Well, how much wattage can I get from here? 1? Well, 1 it is. And then it charges at 1 watt for, until you unplug it and plug it into a different charger. So even if the generator starts spinning up and it is capable of producing more power, the tablet is only drawing 1 watt because it initially detected only 1 watt. So I needed a solution. And what I thought was putting a series of capacitors in parallel with the voltage regulator. So let me reset this simulation and I'll explain what's going on. Basically, there are these 10 capacitors here. And I have 10 100 farad capacitors that are each rated for 2.7 volts. And this morning going down a hill, I saw on my voltmeter that I was getting, 25 volts. And this was down a steep hill going pretty fast. So I figured, well, okay, if I put 2.7 volts and 10 of them in series, 27 volts, I should be safe. I don't think I'll be going much faster than I did down that hill on my bicycle ever. Yeah. So what's going to happen is I'll say, okay, I want to go ride my bike. I'm going to give these capacitors a little charge. Boom. So I plug in a wall charger. And now obviously these aren't going to be balanced, so I'll have to deal with that later. This is just an idea for now. And okay. So disconnect the charger, and the tablet is plugged in, and what's going to happen is it's going to first draw power from these capacitors. Okay. Then I start pedaling. And as I get enough power to the wheels and enough power to the generator, I start putting electricity back into the capacitors. You can see this yellow line right here is the current draw, and it's going above the 0 line, which is this white line right here. So initially, when I'm not pedaling, tablet gets power from the capacitors, and it says, these capacitors can supply, 7 watts. Okay, charge at 6. Oh, I didn't do the voice, sorry. These capacitors can charge at 7 watts, or they supply 7 watts. I want to charge at 6 watts. Okay, because the tablet has a maximum of 6. I forgot to mention that. And then, as I start pedaling, I put power back into the capacitors. I mean, it sounds like a good idea to me, because now as the generator spins up and it's able to supply, it's rated for 7 watts, and it's able to supply all that power, I'll put energy back into the capacitors, and I'll continue charging my tablet, but this time at full speed, or at least a better speed than 1 watt, right? All right, now obviously I'm not a professional electrical engineer, so if any of you watching are cringing right now saying, no, don't do that, feel free to leave a comment below, and I am very open to suggestions. I will have to figure out how to balance these capacitors. But, this seems like something that would work. And I have the capacitors. They're 100 farad capacitors, so I may as well use them, right? And, yeah. But, some of you might know better about this stuff than I do, so, tell me about it. I appreciate your suggestions, and, yeah, I will take comments into consideration. So, yeah. Notice how I'm just stalling for time so that we can watch these, the green and red colors flash back and forth. Wait, I'm not in sync. Hold on. 1, 2, 1, 2, 1, 2. Yeah, there we go. Yeah, baby. Well, I guess that's it for now. Leave a comment, don't forget to like the video, and subscribe. And until next time, I'll see you guys in the next video. Bye-bye.